Hello everyone, welcome to lesson 11. We're very glad that you could join us today. Let's get started. Okay, well, first of all, big thanks for coming back. We have successfully navigated through the first 10 lessons of the course, which represents halfway through the course, and now we are starting with lesson 11 on the second half of the course, which is another 10 lessons. Yay! Now that we have a considerable amount of theory under our belts, we are going to be changing the lesson format a little bit. Previously we had quite a lot of theory in each lesson, and we also had you copy a lot of stuff straight off the screen into your Scratch editor. Now we're going to mix it up a bit, and we're actually going to introduce a bit less theory, and we are going to get you to do more of your own programming during the lessons. The format of that will be, we will pose a problem, we will discuss a potential solution, and then we will leave it up to you to figure out how to write the program to solve that problem in Scratch. Okay. Another change we're introducing is, now that we know who's sticking around in the course, we are going to make a better effort to learn all your names. Unfortunately, we do know most of your names, we just haven't managed to match the names up to the faces. So you'll see as you came in today, we wrote a name tag for each of you and put it on your shoulder or your back. The reason we put it there was so that we could see it while you were sitting and facing the computer. If we put it on your chest, then it would obviously be hidden from us and wouldn't help us that much. Alright, we're also introducing another thing today called noob stars. You can see a little example of a noob star there. Noob is an alternate version of newbie, and newbie is someone who is new to something. You guys aren't new to the course anymore. You've been coming to it for at least 10 weeks now. But we find that a lot of you are still leaving your flash drives behind after class, even though we put on the last slide a reminder for you to remember to take them home with you. So in future lessons, anyone who leaves their flash drive behind will earn themselves a noob star. And we will be showing that on a slide at the beginning of each lesson so that everyone knows who didn't pay attention. Alright, lastly, the course project. We mentioned the course project when the course started. We have been giving you exercises, homework, in other words, to do at home for the last 10 lessons. Now we are going to switch over our focus to the course project. We will discuss that in a bit more detail in the next slide. Sorry, the slide after this one. Okay, last time we covered variable monitors. You can see an example of that over here in this picture, spin count. A variable monitor is a little indication on your stage showing you the name of your variable as well as its current value. Variable monitors can come in 3 flavors. The standard one as you see it now, the brief one which only shows the value and not the label, and then we have a third one called the slider, where you actually get a little slider that you can use to adjust the value while your program is running. We also played the Scratch game show last week, where a lot of you won some nice prizes in the form of chocolates, and I think you enjoyed that quite a bit. We also had a go at writing 3 programs. The first one was Breakout, which was the most complicated. The second one was Dress Up Terror, which unfortunately included some elements which we're only going to cover today, and Polygoner, which was a drawing program. Polygoner was the easiest and should have been possible for most of you, as we covered all the concepts in our lessons to date. We did note, however, that most of you did struggle to complete these programs, so we are going to be going through them step by step, starting in today's lesson, showing you exactly how to do them. We hope that this will help you with your planning of your project for the course. We also had homework problems from last week, problems 5 and 9 from your sessions 9 and 10 folder. As I mentioned earlier, this is the last time you'll be getting homework problems, because your full focus should, from now until the end of the course, be on creating a project for the course. And of course you can get all the information regarding the last lesson on our website at www.introtech.co.za/lesson-10. Alright, what are we going to do today? today we are going to learn how to use these 9 blocks on the right here. Alright, we've got the first one, which is ask and wait, which has a friend called answer. Then we've got the 3 inequality blocks, the less than, the equal to, and the greater than. Then we've got the mod block, which is something new, which will help us to figure out whether a number is odd or even. And then we've got the join block, when we want to join things together. Then the most important thing for today is your IfThen and your IfThen else blocks, which are decision blocks, which allow you to change the way the program behaves based on the input in the hexagonal block here. And if you may have noticed, this shape here is the same as the shapes of these inequality blocks. So it's quite important that you understand how these work so that you can use your IfThen and your IfThen else blocks. Then, as mentioned, we're also going to go through how to create your Polygoner program that we went over last week. We'll go over it in more detail today, so hopefully you know exactly how to do it. Alright, getting started. We are getting started with user input. Up until now, everything you've done with your programming in Scratch has all been defined when you've written your code, when you've put your blocks together. So for today, we are going to go through the ask and wait block, which will allow you to get some information from the user who is using your program, which in most cases will be you or your friends. So the ask and wait block has 2 components. The first one is the ask and wait, shown here, and the second one is the answer block, which we'll see in our examples just now. When you have the ask and wait block in your program, it will either appear in 2 ways. If you have a sprite that is doing the ask and wait, it will put the question in a speech bubble, and it will ask for the answer to be put in this block down below. You can tell it to accept your answer either by clicking on this blue circle with the white tick in it, or you can just hit the enter button. If you put your ask and wait on the stage, or your sprite is invisible, then this speech bubble up here will be included in the block at the bottom where you type your answer in. Again, you type your answer in and either click on the blue button with the checkbox, or you hit the enter key for the program to accept the answer and continue. Only when you click on the blue button or hit the enter key will the program continue, because as you can see here, this is an ask and wait block. So it waits for you to tell it you are giving it this as your input. Alright, our first example, we'll have a look at this quickly, is the ask and wait.sp2, which is found in your session 9 and 10 folder on your flash drive. Consists of 4 blocks. The first one is when space key pressed, so this code only runs when you press the space key. Then it says how old are you in our ask and wait block, and as I said, the ask and wait block has a friend called the answer block, and you can see we are using it in 2 places here, and we are using it inside a say block in both cases. The first one is a say for 2 seconds, and the second one is a say without a time limit. Without a time limit means that that is going to stick around until the program ends. The first one here with the 2-second limit means that it will say it for 2 seconds and then disappear. If we have a look closely at what it's going to say, we'll see there's a new block here called the join block. The join block consists of 2 pieces. Okay, there are usually 2 white blocks. So the first one has got UR and in this line, and in the second line it's got in 10 years you will be. The second white block has been replaced by the answer in both cases. Alright, so the join is going to say UR and take whatever you put in as the answer and use that as the say in the speech bubble. In the second one, we are working out how old you are going to be in 10 years from now. So we use a maths operator block, being the plus one, and we're taking our answer and adding 10 to it. And that's how we're working out how old you're going to be in 10 years time. So let's load this script up into our Scratch and see how it works. Okay. So there's our block. 4 blocks. When space key pressed, how old are you? Say you are however many years you entered, and say in 10 years you will be however many years you entered plus 10. So let's run it. Remember, it only works when you press the space key. So now we're going to type in a number, say 20. It says you are 20 for 2 seconds, and then it goes to the next line and says in 10 years you will be 30, which is 20 plus 10. Okay, so that was example 1. As you can see here, we used the answer block twice, and in each case it will have the answer that you typed in the beginning. In the next lesson, or the next exercise, which is ask and wait 2.sp2, which you can find in your session 9 and 10 folder, we ask the question twice. Now, in this case, every time you ask a question, it puts the answer in the answer block. So if you answer 2 questions, it will replace your first answer that you got from here with your second answer, which you got from here. So if you want to remember what your first answer is, you're going to need to set up a variable to store that answer, because it will get written over when you ask your next question. So you'll see we've got a first initial variable here and a last initial variable, and we are setting those both equal to answer after we ask the questions. Then in our say block, we've got a bit more complicated here. You can see we've got multiple joins. There's 1, 2, 3, 4 joins. So the first one joins the last initial and a full stop. The second one joins a full stop and the last initial plus the full stop. The third one joins the first initial plus a full stop plus the last initial plus a full stop. And then the fourth one joins hello. So it's going to say hello, your initials with full stops in between. So let's go and have a look at that. Alright, there's our blocks. When space key pressed, again, this is only going to run when we press the space key. It's going to ask for the first initial, store it in the first initial variable, ask for your second initial or last initial, store it in the last initial block, and then it's going to do a say, joining everything together. As you can see, here are 2 variables, first initial, last initial, and we've checked the checkboxes next to each one, which means they show up as variable monitors. Now these are local variables, or variables that belong to the sprite, which is why we've got the sprite name in front of the variable name. And there you can see what the current values are, M and S. So let's run our program. Hit the space key, enter your first initial, hit the enter key, enter your last initial, hit the enter key, and there it says hello, comma, or hello full stop DL. So that is how our program works. Okay. Alright, now like I said, it's time for an exercise. So you need to do something on your own. So what are we going to do? We are going to write a program where 2 sprites, in this case the cat and the polar bear, but you can choose any 2 you like, ask each other for their names and then greet each other with their names. Alright, so you can see there the cat says, what's your name? You type in the name of the polar bear, and then the cat says, hello Bob. And then the polar bear does the same thing. You type in the name of the cat, and the polar bear will say hello to the cat. You're going to need to use the blocks shown below here, and you may use any other blocks that you need. So we're going to need a when green flag click to get the program started. We're going to do a ask what's your name and wait to get the name of either the cat or the polar bear. We're going to use the say command to do the hello cat or hello polar bear, and we need to use the join to match the hello together with the name that we are getting from the ask block. In order to tell the one sprite, we're going to start with the cat, that we are finished, and the polar bear must carry on asking the cat its name. We're going to use some broadcasting. So when the cat is finished, we're going to say broadcast over to sprite 2, and then on the polar bear we are going to say when I receive over to sprite 2, it will start asking the cat its questions. Now the code that we use on both the cat and the polar bear are going to be exactly the same, except for the fact that on the polar bear we won't do a broadcast back to the cat, and on the polar bear, instead of using a when green flag clicked, we're going to use a when I receive over to sprite broadcast event. So let's go and see what that looks like. Alright, so as I said, we've got two sprites here, the cat and the polar bear. On the cat, we've got when green flag clicked, say ask what's your name and wait. Then we type in the name, and then we do a say, join hello, the answer, for 2 seconds. It's important to put the 2 seconds in here, otherwise the hello polar bear won't go away. When we're done, we then do a broadcast and say over to bear or over to sprite 2, as was on the slide. Then if we go and have a look at the polar bear, we'll see the code's exactly the same, except instead of having a when green flag clicked at the top, we have a when I receive over to bear broadcast event, and we don't do a broadcast over to bear at the bottom because we're not going to talk to the cat again after we say hello. It's very important to notice that in our block here we've actually got a space at the end of the hello. If we don't put a space in there, then there'll be no space between the hello and the answer, and things will look a little bit strange from a spelling point of view. So let's go back to our cat. Let's start the program. What is your name? The cat asks the polar bear what his name is. We say Bob, hit enter. The cat says hello Bob. Then the polar bear says what's your name? The cat says my name is Jay, and the polar bear says hello Jay, and that's where the program ends. Alright, that was our exercise. Okay, now we are doing something new, relational operators. Okay, we have got 3 relational operators, the greater than, the less than, and the equal to. Now I'm sure you're all familiar with equals to. The only new ones might be the less than and the greater than. Now I know sometimes it's confusing to figure out which one is which, so a simple trick is to read from left to right, like you do when you're reading a book. And if the opening is on the left, then it's greater. So 5 is greater than 2. If the opening is on the right, so the point is on the left, then it's 6 is less than 10. Alright, so if we have a look at our examples here, we've got a variable called price, and we are checking, is price greater than 2,000, or is price less than 2,000, or is price equal to 2,000. Now it's very important to know how these blocks work, because these blocks that are a hexagon shape are Boolean blocks, and we need to use Boolean blocks in our IfThen and IfThen else blocks, which we'll get to in just a minute. So let's look at a bit more complicated example. Okay, here we've got a variable called z, and we are going to set it equal to the answer of this Boolean block. Now remember, a Boolean block can only have 2 answers. It can either be yes or no, true or false, 1 or 0. In each case there are only 2 options. Okay, so z will always only be true or false, or 1 or 0. Okay, so what we work out here in our green block is whether, in this case, x is less than y. Now our values for x and y are over here. X is 5 and y is 10. So we are going to say, is 5 less than 10? 5 is less than 10, so z is going to be equal to true. In this case, x is greater than y. Is 5 greater than 10? No, so z will be false. In this case, x equals y. Is 5 equal to 10? 5 is not equal to 10, so that is false, so z will be false. And in the last one, we've changed it a bit. Instead of using y, we've used a value which we typed in, and the question is 5 equal to 5? And 5 is equal to 5, so we will make z equal to true. Now using variables in your relational operators blocks is very useful in programming. For instance, if you have a game where you are running around shooting zombies. Okay, you can only do that if you have bullets. Okay, so you might have a flag which keeps track of how many bullets you have, alright, and that will determine whether or not you can fire your gun. Alright, if can fire equals 1, then you can fire. If can fire equals 0, okay, then you won't be able to fire. And this is called using a variable as a flag. Now we have an example of the South African flag here on a long, nice flagpole. Okay, the reasons that we have flags is to send signals to people, to show people what is going on far away. That's why we have them on nice long flagpoles. And just the same here, we are using variables as signals or flags to show the program what is happening. We will cover this concept later in the course. Alright, on to some new stuff. Decision structures, the if block. Alright, before we go over the colored bits on the left, let's look at this on the right. This diagram on the right is called a flowchart. It has different shaped blocks, and those different shaped blocks mean different things. This diamond shape is a decision block. Okay, basically you come in at the top, you look at the question, is test condition true? If it's true, then we go out the yes path and we execute these commands, and then we come back in the bottom. If test condition is not true, then we come out the bottom. In both cases we will execute command M. Okay, only if the condition is true do we execute 1 through N, but in both cases we always execute command M. If we look at the blocks here from scratch, there's our if block. Alright, it's got a condition in it. Remember we were talking, the green blocks are hexagonal shape, which means they are Boolean. So they give a true or false value. If the condition is true, then it will execute these blocks inside. Don't worry about the colors here. These are just pretend commands, just to illustrate the concept to you. If the condition is false, then these blocks do not get executed. But in both cases, when the if block is finished, command M will be executed. So let's see how that works with an example. Okay, this example is not on your flash drive, so we're going to type it up quickly in Scratch and see what it does. So we're going to start off and go File New. And we're going to get our when green flag clicked to start things off. And then we're going to go to X0, Y0, which is the center of your stage. And then we are going to point in direction 45, which is sort of up and to your right. And then we're going to bring in a forever block. We haven't covered these in class yet, but forevers are basically carrying on looping forever and ever and ever until you stop the program. Then we are going to move 5 blocks, and then we are going to bring in our if block. So there's our IfThen block. Okay, and now we are going to do a test. So for a test we need our relational operators, and in this case we need our greater than 1, and we are going to look at the x position of our sprite. Okay, there's the x position of our sprite, and we are going to see if it is greater than 0. Greater than 0, remember 0, 0 is in the middle. Greater than 0 is this way. Okay, if you look at the x and y down here, you can see x gets bigger if I move to the right of the cat. If I move to the left, it goes negative. And remember, negative numbers are smaller than 0. So it'll do the if block if I'm over here. It won't do the if block if I'm over here. So let's put that into our IfThen block. And then what are we going to do? We're going to change the look. We're going to change the color effect by 25. Okay, now if our cat is bouncing around the stage, we need to include if on edge bounce. Okay, so that is our program. Okay, remember you can always neaten up your program by right clicking on the scripts area and say clean up, and that'll organize all your blocks so that they are nicely placed on your scripts area. So let's run the program. Now you can see our cat is busy changing color because its X value, which you can see down here, there you can see the cat's X value is greater than 0, and as it moves over the 0 and becomes negative, okay, it stops changing color. Okay, the reason it moves slower when it's changing color has to do with the offline version of the Scratch program. It has a bit of a bug there, but it still works. Alright, so there we go. That's our program. Okay, so now we've done the IfThen. Now if we wanted to check and do something else, if X position was less than 0, we would have to create another if block and put it underneath here to handle the other case. So fortunately we have a short circuit for that. Okay, it's called the IfThen else block. So the top part here is exactly the same as the one that we've looked at, but the bottom else is a new one. So the else block here gets executed when your condition is false. So if condition is true, we do the top block. If condition is false, we do the bottom block. Again, the next command will always get executed after the if block. It doesn't matter if we did the true part or the false part. If we look at our flowchart on the right here, we've got our decision block again. If the test is true, then we come out this side and we execute the commands in the if block, which is this one over here. If the test condition is false, then we execute the commands in the else group over here. And then, as I said, in both cases, we execute the next command. Let's have a look at this in an example. Okay, in this case, we are going to figure out if a number is positive or negative. Alright, and this is where we're going to use that mod function which we spoke about in the beginning of the class. Okay, this example is not on your flash drive, so we are going to cover it quickly in the Scratch editor right now. So we're going to start off and say File New. Don't save what we have. Alright, and we are going to start when space key pressed. We're going to ask the user to enter a positive number. So enter a positive number, and then we're going to use our IfThen else block. So we put that under there. Again, we need to do a check here. So this one is a bit more complicated. We're going to use our mod operator. Okay, now mod is a mathematical term, and it's actually short for modulus. Modulus gives you your remainder of your division sum. So if you say 5 divided by 2 equals 2, remainder of 1, it will give you your remainder, which is 1. If you go 7 divided by 5, it'll go in once, remainder 2. So your modulus will be 2. So we are going to take our answer and we're going to put it in the left side, and then we're going to divide it by 2. And we then need to do a check. And we need to say if the remainder after we divide our answer by 2 is 0, then we know that our number is divisible by 2. And if a number is divisible by 2, then it is an even number. Alright, so now we're going to tell the user what we found out. So we are going to say, alright, in both cases, we're going to use our join as we've done before. Where's our join? There's our join. And we are going to say our answer is even. Now remember to put a space in front so that your answer doesn't end up being joined directly onto is even or is odd, because a number can only be even or odd. Alright, so let's run our program and let's hit our space key, enter a positive number, 6. 6 is even. Hit our space key, 7. 7 is odd. Let's try it one more time. Let's see if that number is odd or even. That is odd, which you could have figured out by the fact that there's a 5 on the end there. Alright, let's carry on. Okay, so nesting of if-then else blocks. Alright, this block down here is the block we've just done, but there is a special case. If we put in 0, 0 is not odd or even. So what we are going to do is we are going to put our block, our if-then else block, inside another if-then else block. And if the answer is equal to 0, then we say the answer is neither odd nor even. Excuse the spelling mistake there. If the answer is not equal to 0, then we do the same test that we did before, and we say whether or not the number is even or odd. Alright, we're not going to do this example in real time, but the point we're trying to illustrate here is that we can nest our if-then else blocks. We've got one there and then another one inside it. This example is not on your flash drive, so if you want to try it, you're going to have to copy it off the slides or pause the video and copy it off the video. There's another really cool example on your flash drives in your session 11 and 12 folder. It's called the line follower program, and it uses the if-then else and if-then blocks that we've been looking at so far to get a cat to follow a line. Now the program has a line included, but you can actually go and edit it and change the line and it will still follow that line. I really encourage you to go and have a look at that. Alright, Polygoner. Polygoner was one of the programs that we tried to get you guys to do in the last lesson. Okay, some of you succeeded a bit more than others. Okay, so we decided we're going to go through it with you step by step and help you get there. Alright, so the first thing is to look at the program and see what it is made up of. Okay, the first thing to note is that we've got two variable monitors on the screen or on the stage. The one is called sides and the other one is called repeat. Sides is set to a value of 3, repeat is set to a value of 3. But remember the sliders here at the bottom, the little white circles, we can slide them to change the value of the variable. Then if we look what's on the screen, in this case we've got 3 sets of 3 triangles. Okay, and each triangle has got 10 little triangles inside it. So there's 1 triangle, 2 triangle, 3 triangles, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 triangles inside each triangle. Now it's important to note that the color of each triangle is the same. So you can see the big outer triangle is red for all 3. This one, which is fourth from the end, is all pink. Okay, the second from the end is all yellow. Now that is an important clue for us, because we did a similar exercise previously where we drew a spider web. But in the case of the spider web, we drew all of the little triangles first before moving on and drawing the next triangle. Now in that case, if we did it that way, the colors would not be the same for every triangle. So the clue here is that because the colors are the same, that means we draw all the same size triangles at the same time. So we start off and draw all 3 small triangles, then we do the next size triangle and the next size triangle, and we basically move out drawing all the same color triangles in one go. So if we are changing colors and if we're changing sizes and we are rotating our shapes around the center, we're going to need what we call program variables. Program variables are used by the program and they're exactly the same as user variables, except that the user can't change them. And the only reason they can't change them is because we haven't put variable monitors on the stage. Now in this case we are going to need a size program variable to keep track of the size of these little triangles. We're going to need a color variable to keep track of the colors, and we're going to need a rotate variable to figure out what angle to draw our triangles with. Okay, now bear in mind we've got triangles in the picture here, but we've got a sides variable. which means we can change the number of sides on the shape. So if we set it to 4, it would be a square. If we set it to 5, it would be a pentagon. And you can set it to almost any number of sides that you want. Okay, then the last thing to note here is program constants. We haven't really spoken about that, but program constants are numbers within the program which don't change. They are essentially opposite of a variable. And the constants in this case are going to be the shape count, which is how many shapes inside. And as I mentioned, we have 10 little triangles inside the big triangle. And we have the size increment. How much bigger is the next triangle than the previous one? And in this case, our increment is going to be 5. So if we start off with the baby triangle here at 5 on each side, then the next one will be 10 on each side. And the third one will be 15 on each side. So now that we've looked at our program, we know we are going to need 5 variables. Sides, repeat, that's 1 and 2. Size is 3, color is 4, and rotate is 5. Only sides and repeat will be shown on the screen using variable monitors. Then we're also going to have 2 constants in our program, the shape count, which is 10, and the size increment, which is 5. Alright. So we are going to do our program in 2 parts on the same sprite. And if you notice, we didn't see a sprite on our screen, so that means we are going to have to hide the sprite when we start writing our program. So, program in 2 parts. Part 1 is the big stuff. Okay, when we click on the green flag, we are going to fiddle with the size of the triangles, the color of the triangles, the rotation of the triangles, and have a look at the shape count and the size increment. That's part 1. Part 2 is going to be a custom block which we create called draw shape. Because remember, we need to be able to draw any shape. Triangles, squares, pentagons, hexagons, you name it. And that is going to have a few parameters. Okay, our purple draw shape block is going to have a start angle, a color, and a size. Alright, now you might think, well, I need to say how many sides my shape is going to have. But we don't really need to, because the number of sides is a global variable. If we go look at our stage, there's our number of sides, and because it doesn't have the sprite name in front, that means it's a global variable. So our custom block can read that value without us having to pass in how many sides we need. So this is a very good example of bottom-up programming. So we'll start off doing the simple thing, being drawing the shape, and then we'll move up to doing the bigger stuff, being how to draw all the shapes together and change the colors and sizes, etc. So let's start off with part 2. We're going to define a custom block called draw shape with the parameters start angle, color, and size. We're then going to point in direction start angle. We're going to put our pen down, because if we don't put the pen down, nothing will get drawn. We're going to set pen color to color. Now color is one of our parameters that we are passing in, and then we're going to repeat sides. Remember, sides is a global variable, so we don't need to pass it in as one of our parameters. And we're going to move size steps. Okay, size is one of our parameters, and then we're going to turn clockwise 360 divided by sides to get our angles correct, and then we're going to lift the pen up when we're done, so that we don't draw on the stage when we're moving around. So let's switch over to our Scratch editor, go File, New, don't save, and we're going to start off by creating our custom block. And we are going to call it Draw Shape. We're going to click on our options, because we want to add some text first. So we're going to start off with our start angle label, and then we're going to add a number. I'm going to call it start angle, and then the next one is going to be color. Alright, and then we're going to add a number called color, and then the next one is going to be size, and we're going to add a number called size, and then we click OK, and there's our custom block. Now we need to tell the custom block what we're going to do. So we're going to start off, and we're going to point in direction start angle. So we're going to drag our start angle and put it in there. Then we're going to put our pen down so that we can start drawing. And then we're going to set our pen to the color that we pass through. Now just note here on your palette, we've got set pen color to color with a colored block, and we've got set pen color to a number. We want to use the number 1 because we are passing the value in of the color as a number. And we put our color in there. Then we are going to do our repeat. Okay, and we're going to repeat the number of sides. Now remember I said we need to set up our variables. So we need to go and make a whole bunch of variables. So we're going to make one sides for all. We're going to make one color. Sorry, not color. Sides repeat. Okay, those are our 2 slider variables. So to change it to a slider, we right click and say slider. Right click and say slider. So there's our sides and our repeat. Now it's important that we can set limits, a min and max limit on our slider to make sure that we get sensible things happening. So right click and go to set min max. So we are going to say our number of sides will be anything from 3 to 10, and then our number of repeats, set slider min and max, will also be say anything from 2 to 10. Now you'll see the min value is automatically set to 3 and 2, and if I drag this, it doesn't go above 10 and it doesn't go above 10. So those are our 2 global variables. Alright, we also might want to go and change our stage and make it dark so that we can see what's happening. Alright, and we choose our paint pot, and there we've made it black. Okay, going back to our cat sprite, as I said, we don't see the sprite drawing, so we are going to hide the sprite. Okay, now we need to go and create some other variables. Remember, all our code is going against our cat sprite. So we've got repeat, sides. Let's go back to our slides. We've got size, color, and rotate. We're also going to need as variables. So make a variable size, make a variable color, and make a variable called rotate. Now these are all program variables, not user variables. So size, color, and rotate don't need to have variable monitors on the stage. Now to get back to our draw shape, we need to repeat sides. So we are going to go and put our sides in there, and then we are going to move size steps. So there's our size, not this size, don't get confused. We want to take that size, our parameter up here. And then we are going to do some turning clockwise, and now we need to do some maths. So we go and get our division block, and we go 360 divided by the number of sides, which is our variable over here. Okay, and we put that in over there. Alright, and then when we're done, we go and lift our pen up. Now if we run this, it's not going to do anything. Okay, so we're going to have to create a little test thing to test our draw shape. So we can set the start angle to say 45, set our color to 50, and set our size to 50. Now if we test it, there's our triangle. Okay, and the triangle is 3 sides because this was 3. Now it's 5 sides. Now 6 sides. So we know this works. So we can take this away. We know that that works. So let's go back to our slides. So that was our bottom-up design, starting with part 2, where we did our draw shape custom block. Now let's move on to part 1, which we are going to finish with. So part 1 has got the following steps. We have a when green flag clicked, we lift the pen up, we set the size to 5. Remember, size is one of our program variables. We set repeat to 10, that is our constant, 10. We set rotate, which is a program variable, to 0. Set our color to a random color. Color is also a variable. We go to 0, 0, which is the center of the stage. Then we repeat, repeat. This looks a bit strange, I know. Repeat is the block name, and repeat is also the variable name in this case. It'll become clear when we get into the code. Then we call our draw shape function. Then we change rotate, our program variable, by 360 divided by repeat. And then we change our size by 5. Alright, let's go and have a look at that. Okay, so we need to start off with when green flag clicked. Okay, and then we need to put our pen up so that we don't do any drawing while we're setting things up. And now we need to go to our variables and we need to set size to 5. So that's going to be the size of our first shape. Then we are going to do a repeat 10 because we are drawing 10 shapes of each kind, or 10 different sizes. Then we're going to go to our variables and we're going to set rotate to 0. So that's going to start us off pointing straight up. And then we have to go and set our color. So we choose that again and we change our variable to color. Now we want to set it to a random value. So we go pick random and your colors go from 1 to 200. So we put that in there and we set a random color. Then we go to X, Y, 0, which is the center of the stage. And then we do another repeat. Okay, this time we are going to do repeat of the repeat value shown here. So we go get our value, our variable, and we put it in there. Alright, now we need to call our draw shape. So we go to our more blocks, and we put our draw shape there. Now start angle is going to be our rotate variable. Okay, let's go get our rotate variable. Our color is going to be our color variable, and our size is going to be our size variable. Okay, and you see that matches up. Start angle, rotate, color, color, size, size. Okay, then we need to change our rotation. So we're going to use our variable, and we're not using that one. Yes, we are using that one, changing it by. And then we're going to do a function in there. So we're going to go to our operators, get our divide, good old 360 degrees, divided by our repeat variable, and we're going to put that over there. And then our last thing we need to do is change our size over here by 5. So that's how big we make each shape. Okay, so now we've got our code. So let's right click, clean up. Okay, that didn't help because it cut things off a bit. So let's move it back there. Okay, let's stop our program. Let's start. Okay, that looks fantastic. Okay, let's change our repeats. And let's try it again. That looks fantastic. Okay, the only problem is that we are drawing over the stuff we've already drawn. So we actually left something out here. We need to go and do a clear here at the top every time we run the program. So if we run it now, you can see that it's drawing quite nicely. And if we run it again, it's going to wipe out what we've already done and draw something new. Now this is very pretty, but it can take quite a while. So we can speed that up in two ways. We can either speed it up on our custom block and check the run without screen refresh, which will make it go quite a lot faster, or we can take that off, okay, uncheck it, and we can go and switch on turbo mode, and turbo mode will make it almost instantaneous. So if we make something really complicated, boom, there you go. And that is how we do Polygoner. I know it looks a bit complicated if you look at what it draws, but once you've been through the code, it's actually quite simple to follow. Alright, so that's what you should have landed up with, and that is what we have on our website. Okay, homework. Your homework for this week is to work on your project. Okay, next week we're going to be asking you if you've picked partners. We're going to be asking you if you've got an idea for your project and whether or not you've actually started working on it. Okay, please check out our supplementary information pages on our website. Lesson 10 for last week and Lesson 11 from Monday next week. Alright, next lesson we're going to cover logical operators, which are and, or, not, and you can see an example of those down there. And then please, before you go, shut down your computer and don't forget your flash drive. You don't want to get a newbie star. Thanks very much for coming, and we'll see you next week.